Hello, class. Today we're going to be talking about environmental problems, their causes, and sustainability. This is our first chapter. I suggest to you very strongly to read the first chapter, um, maybe before or after you listen to this and watch this PowerPoint. Um, they will both work together in a way that'll let you understand the material in a much deeper way. Once again, this is EVSC 404, which is Environmental Science 1. And as you've seen on your syllabus, as well as myself, if you've come to see me or seen me the first day of class, we're using the textbook Environmental Science by Miller. You don't necessarily have to have the most recent edition, but it's important for you to have the book. All right. So, one of the main themes in this course is going to be sustainability. Right? When we talk about sustainability in this class, we're not going to try to regulate it to just the environment, even though that will be our focus. But I want you to continue to stretch your minds forward to understand that sustainability blankets human activity and interaction. So we're not just talking about the environment, we're talking about economics, we're talking about society, we're talking about health, right? So these components are going to have to be melded in your mind. But when we're talking about environmental sustainability, right, in particular, there are three important factors that this book wants you to remember, and I would like you to remember as well. That's solar energy, chemical cycling, and biodiversity, right? So we're going to try to deal with these things in a real way throughout the semester, right? Solar energy, we're simply talking about the ability, the natural ability as well as the synthetic ability of organisms to capture the energy that's coming off of our sun and utilize it for other purposes in sustaining life. Then we're going to talk also about chemical cycling, right? So in terms of chemical cycling, we know that there are inorganic and organic chemicals on our planet, right? And there are processes that will take matter from inorganic form to an organic form, and then from an organic form into an inorganic form, right? So we're going to talk about that process within the ecosystem or within the biosphere. And the last thing is biodiversity, right? We're going to look at the actual life and how life is sustained through these systems that we speak about. Okay, so one of the first things that we want to understand is natural capital, right? Here we have natural capital equals natural resources plus natural services, right? So, I mean, another way to say that is natural capital is the sum of natural resources and the services that they bring, right? So, when we think about this, we should think about it in terms of a system, right? A system is an agreed upon unit which is separate from its environment, right? So it survives and functions over a specified time and attains expected lifespan, right? This is, in general, we're talking about a system. And a sustainable society, a society which manages its economy and population without exceeding all a part of the Earth's ability to adapt, right? So we're living off income rather than capital. Uh, Going back two slides, the definition of natural resources are materials and energy that the environment, uh, energy in the environment that we need to meet our desires. And natural services are the processes in the environment which meet human needs and support life. For example, topsoil renewal, water purification, etc. An example of this, we can just talk about the natural service that soil provides. Soil is a natural resource, right? And the natural service that it provides is it helps with our water purification as water moves down the soil profile. It also supports the construction of places of rest and construction of habitats. It also serves as a medium to grow food, right? So those are some of the services that this natural resource of soil provides, right? So going back, natural capital of soil equals the actual natural resource of soil plus those services that we talked about: water purification, uh, actual foundation to build structures on, uh, as well as a sink. Okay, so we just introduced the concept of natural resources. But when talking about resources, we're just talking about anything that's obtained from the environment to meet our needs and wants, right? And we can classify those into three specific areas, right? You have perpetual resources, renewable resources, and non-renewable resources, right? So renewable resources, right, are the first two, are perpetual and potentially renewable. So in terms of perpetual, we're talking about something that's inexhaustible, uh, given the human conception of it. So the sun, I mean, we are in no way in the conceivable future going to run out of solar energy, nor wind. So that's perpetual, right? So beyond the foreseeable future, we don't see that changing. Potentially renewable resource can be replenished fairly rapidly, right? So in that sense, we're talking about, forests, wildlife, and animals. If these things are utilized for clothing, shelter, over time, a fairly quick amount of time, they can be replaced and start serving other purposes as well. So the non-renewable resources, we see this in some of the elements that we find throughout the terrestrial parts of the earth, so also under the water. So the examples of that can be metal, iron, and copper, uh, non-metallic things such as sulfur, clay, and phosphates. The energy resources. This is the ones that we all hear of in the news, right? Fossil fuels. So one of the things that we looked at that just in any human society that has to be considered um, is the yield of that society from the natural environment. Um, if you take more than you can actually put back or replace, you're on an unsustainable track, right? So now the conception of a sustainable yield has to come into place if the society is going to be sustainable, right? So sustainable yield is the highest rate at which potentially renewable resources can be used indefinitely without reducing the available supply, right? So what we're simply saying is sustainable yield is a yield in which a society is not taking more than they can actually replace, right? They're balancing their books with nature. Um, so something to consider when we're talking about yield. Um, that may actually reduce the yield from certain natural resources is environmental degradation. And resources naturally replace themselves, but when that's exceeded, sustainable yields exceeded. Right. So this happens in the cases of urbanization, overgrazing, reduction in biodiversity, and soil erosion. Right. If you erode soil from one place, you're actually degrading the Earth's ability at that point to provide those services that we talked about earlier of the soil. Urbanization is another one. When we talk about urbanization, we're talking about impenetrable services. Uh, by and far, this is one of the major issues with urbanization. So you're just losing uh, hundreds, even thousands square miles of the Earth's ability, or really the soil's ability, to take precipitation, just water, and let it go through the natural hydrologic cycle. So another consideration that we have in terms of living sustainably is the tragedy of the commons, right? This is when one of the consequences of environmental degradation, right? So to think about tragedy of the commons, we have to first establish common property. This is property owned by no one, but available to all users free of charge. Most potentially renewable resources, clean air, the open ocean, its fish, migrating birds, etc. Right? These are things that are not owned by anyone. Then we have environmental degradation of this common property. That's what we then term tragedy of the commons. So some of the solutions that has been put forth of the use of common property is to use the resource below sustainable yields, reduce population, regulate access, or both. A problem is that it's difficult to determine sustainable yield of forests and grassland. And then we also know that yield naturally varies according to climate, weather, and other unpredictable factors. So when we're talking about environmental degradation, this is a perfect time to bring up this idea of pollution, right? Which is any addition to our natural resources or food that threatens our survival and activities. So when we talk about types of pollution, we usually talk about point source and non-point source, right? Point source pollution is pollution where you know where it's coming from, right? So say if we are in we are in an ecosystem that is largely dependent upon its rivers, right? We put a industrial age factory or mill by the river, right? Characteristic of that factory is its release of liquid pollution into the river tributaries in the area, right? The fact that we know that it's coming from that factory is a point source pollution. An example of the opposite, non-point, is that we know that during the warmer months, when the entire Mississippi, all the communities along the Mississippi are actually planting and carrying out agriculture. We understand that the pollution of the Mississippi rises because of runoff that are coming from these farmlands. But we can't necessarily tie the actual pollutants back to an exact farm, right? Because the actual precipitation drains that entire river basin into the river. And it's virtually impossible to track the pollution back to the exact farm. Sorry. So the effects of pollution, they disrupt life support system of humans and others, damage wildlife, human health, and it can be a nuisance, right? So we can have something such as noise pollution that's being brought by something like a new highway. Right? So we see the disruption of life support systems of many ecosystems through pollution. So some of the factors of pollutions that come into play is its chemical nature. What is the ability of that chemical in a natural setting? What organisms does it impact? Right? The very chemical structure of all chemicals is what makes them biologically active or inactive. So the chemical nature is very important. And then the concentration. How much of this pollutant do we have, right? Some things aren't dangerous at certain levels, but when you increase their concentration, they then become very dangerous and hazardous to health. And then persistence. How long does this pollutant stay in its common form in the ecosystem? How long does it persist in this state? How long does it remain in danger? So then we listed some possible pollutions and then solutions to pollution. So the last part of this chapter is going to be on population growth, and we're going to actually get to that in a separate presentation. So we'll end this one here, and if you have any questions, please contact me so that we can discuss it and we can stretch forth our understanding of the topic. All right, I'll see you next time when we speak about population growth. All right, thank you. Bye-bye.